Okay, today we are doing problem 1296, divide array in sets of k consecutive numbers. So we got some array, positive integer k, and we want to divide it into array into sets of k consecutive numbers. So first of all, k should divide the size of the array, and next, we can simply go element by element, right? We can store for each element in like a hash map, like their indices, but we would have to sort for that. Oh, that's true, it's not sorted. That's interesting. Yeah, my assumption was we sort, but we don't have to. Like, we can use a multiset and start from smallest element and try to find next k minus 1 elements. If cannot be done, if it cannot be done, then we return false. Multiset int ms nums begin nums end, and then we go while not ms empty, if num size percentage k return false, and then what? Auto it val it. No, that's like ms begin maybe, and then auto it ms, and then you wanna do like for int I is k minus 1 and I plus plus, and now if not ms count val plus 1 return false, otherwise ms erase val, and we wanna do this. Then we wanna do val plus plus ms erase val. Return true. This should pass, I think. No. Interesting. 1, 2. Why is that? 7? Why would you need 7 though? Oh, ms erase ms lower bound val. Of course. Okay, so you can only erase so this will be slow. So that's n log n approach. You could do n log n by sorting and then storing indices over all my days. That is ridiculous. Auto it ms begin plus plus, and then ms array previous it, and then if it return false, otherwise val plus plus, it next it ms erase previous. I hope that like not lower bounding will be faster, but I'm not sure. Ooh. What the hell? Maybe it breaks the chain or something. Oh. I mean, okay, we can do like a map. And then this is like ms begin first. Okay. And then this is ms begin, and then if previous iterator second is 1, then we erase it, and then if this doesn't hold, first previous iterator second minus minus if previous iterator like this, like this. Okay, maybe this will pass. Okay, this passes and it's faster than half of the solutions. Question is, can we do in linear time? Not sure to be honest. I mean, k could be a lot, but in the end, like, even if we consider all the previous starting points, yeah, but if there is a large gap, yeah, not sure. Maybe if they could do sorting in ON. Okay, so there is also another linear solution, which, because why start like with, what numbers can we start with? Like it's a number that doesn't have a previous number. And if we remove that sequence, well, a new such numbers can be formed, right? Which we can guess by updating the counts. So there was a nice solution in the linked by Stefan Pochmann of another guy, which basically works like this. So we have a ordered of counts, nums. We do this, right? And then Then we want to find roots. If sunt x minus 1, then st push x is root. And now while we have while not st empty, root st top st pop, root no, I0 no root I is less than root plus k I plus plus. And now if not count of I return false, otherwise count of I minus minus, right? We removed it. And now now we want to check this. So if count of I and not count of I minus 1, roots push I. And I think that's it. Okay, maybe I could call it roots, but this didn't work. Let's see, so 1, 2, 3, I. And then we just check if something else remained. Okay, false sometimes, not sure why. That is weird. Let's see. Why would you push it there 3 times exactly? Oh. That is weird. Yeah, because we push it back in when count of I Yeah, because after we remove the first one, there is still one more in. So we push another root. So we push 3 roots. So technically, pushed, we should have this, so, and not pushed x, and then pushed x plus plus. Yeah, that should work. What? What? That is ridiculous, brother. What? Why didn't we start 7, 8, 9? Okay. If if count root plus k, roots push root plus k. Yeah, maybe I should have like that is okay. Interesting. I understand what is the problem, but so what was the solution here? If not di, oh my god, bro, hell nah. That is insane trick. So if I is less than root plus k, then we only do this. That is so interesting. Okay. That is an amazing trick, to be honest. Wow, okay. That is impressive. What? What? Okay, that didn't help. I did a bit. If not cent I, return false, else cent I less. Yeah, because this is extra and this is extra. Okay. If I remove this. I mean, it's barely faster, to be honest, even though it's ON. So, I mean, I guess root removal ON. Yeah, I should give credit where credit's due. Credit to solution. Of starting from the minimum of the remaining elements. Let's start with let's start removing from any element that does not have a previous element, and while removing the chain, update the counts of elements and the list of, and then the potential list of the list of elements without previous element. We just keep count. First we just count each element and push onto a stack the ones without a previous. While there is something in the stack, we remove the root if its count is 0. We skip processing, otherwise we try. If we still have root plus k have all elements from root plus k, and decrease their counts, we also have to try if root plus k does not have a previous element. In case of k3 and nums equal to 1, 2, 3, 4, 5, 6 would be in the roots at the start and nothing after removing 1, 2, 3 without the root plus k check. ON where size of nums, since we first count the elements which we store hash map, and then we put each element in put push and pop each element from the stack at most once of n, since we have to keep counts of all elements at the start. Okay. I mean, interesting, but it's not much faster constant factor wise than maybe stack is slow. I don't know, but I don't care. Goodbye.